Since we've understood what a median is just a while ago, let me introduce you to some other related terms called quantiles and percentiles before we go and understand the equivalent of standard deviation called median absolute deviation. First, let's understand what are quantiles and percentiles. Right? First, I'll explain you what is a percentile so that explaining what a quantile is becomes very, very straightforward. Okay, let's go and take an example here. Let's assume I have a data set X, right, with 100 values. Let's assume this is sorted. I'll just put X subscript S, which basically means it is sorted, right? Suppose if I have 100 values here, okay, so my N equals to 100. Now, given 100 values, there will be a value at the first index, second index, third index, fourth index, so on and so forth at the 100th index, right? Because there are 100 values here. What will be the median? So median of X is, since we already have the sorted value, we take the 50th value corresponding to the 50th index, and we take the value corresponding to the 51st index, right? So let's assume we have some values x1 and x2 here, okay? We take the average or the mean of x1 comma x2 as the median, right? As the median of x. So if you think about it, what we have just done is a very, very simple idea. So I'll just erase this. Okay. So what we have done is we have taken the 50th percentile. So we have taken the 50th value in a sorted list of 100 values. So if you pick the 50th value, it's called the 50th percentile value. This is not percentage, this is percentile. Percentile basically says, where do you lie in the sorted list? If you lie at the 50th rank, right? Suppose I sort all of them. Since there are 100 objects, since I've sorted them, I can think of them like a rank, right? If the value that is at the 50th position is called the 50th percentile value of X, right? So let's assume this array is X itself. Let's assume this is an array, not a set, okay? Let's assume this is an array, right? And these are the indices. So the value of XS corresponding to the 50th value, 50th value, whatever the value is, this value could be any value depending on what this array is, right? That is a 50th percentile value, and 50th percentile value is nothing but your median. If you think about it, your 50th percentile value is nothing but your median, right? Similarly, what is 10th percentile value? What is 10th percentile value mean, right? 10th percentile value is nothing but in the sorted array you pick the 10th value, right, corresponding to the 10th index. What does the 10th percentile value tell you? It tells you that about 10% of points are roughly less than this value, right? And about 90% of points are greater than this value. That's what the percentile value is telling you. The percentile value is telling you what percentage of points are less than this value and what percentage are greater than this value, right? That's what a percentile is. So we call the 25th percentile, so the 50th percentile, we call it a median, right? The 25th percentile, 50th percentile, and 75th percentile are called quantiles. And the 100th, of course, and the 100th percentile. Quantile, basically median is basically the half. Quanta basically means you're basically breaking into 4 regions. The 25th percentile value will tell you that 25% of all your observations are less than this value. 50th percentile value is nothing but median, which means 50% of values are less than this and 50% of values are more than this, right? So here 25% of values are less than this and 75% of values are greater than this, and so on and so forth, right? So quantile is just a term. So if somebody tells me what is the third quantile is nothing but the 75th percentile. The second quantile is nothing but the mean. The first quantile is nothing but the 25th percentile, and the fourth quantile is nothing but the maximum value, right? So a related terminology. So let's look at some quantiles here. Okay. So if you look at, so quantiles can easily become, your NumPy basically has percentile function, and you can say which percentile you want. Here I'm saying that I want all the percentiles between 0 to 100 with a gap of 25. So if you look at the output of this, what it gives us is, it tells me that for iris setosa, my 25th percentile, my 0th percentile, so this is 0. So in this case, what it's doing us is, it's giving us the 0th percentile, 25th, 50th, and 75th, right? These are the quantiles. Different libraries implemented differently. You can have 0, 25, 50, and 75, or you can have 25, 50, 75, and 100, right? I think NumPy is implementing so this is the minimum value. The minimum value we know is 1. This is nothing but your median. This is your 25th percentile. This is your 50th percentile, and this is your 75th percentile, right? And the 100th percentile is nothing but, so when you say quantile, so if you look at this code is very, very straightforward. You are saying that you want, so what actually the reason we are getting 0, 25, 50, and 75 is because of this. Because I said, get me the values, get me the percentile values from 0 to 100 with a gap of 25. Okay, so of course 0 will be there. 0 plus 25, 25, 25 plus 25, 50, 75, and 100 won't be there because it's a max value, right? So these are the percentiles, the 0th percentile, 25th percentile, 50th, and these are your quantiles. Similarly, you can also get 90th percentiles, right? 90th percentiles are very, very useful. Let's look at the 90th percentile values, right? The 90th percentile value for Setosa is 1.7, for Virginica and Versicolor are 6.31 and 4.8. Now, you might say, why the heck a 90th percent? Why did you pick up 90th percentile specifically? So let me give you an intuition. Let me connect it with a real world use case. So let's say, Jum, you work at an e-commerce company like Amazon. Of course, I'll keep bringing up Amazon examples because of my personal biases. I love this great company. Again, FYI, I worked there for 5 years, so I'll have my biases. Please bear with them. Sorry. So let's assume the time it takes. Suppose I have an array of all the times it's taking for a product to go from the time a person ordered to the time it's delivered to him. So let's assume I have delivery times, right? So let's assume I have delivery times. So it could be, let's say, 1 day, 1.5 days, 2 days. So let's assume these are all delivery times of some, let's say, 10K shipments that Amazon did in a short duration of time, right? Now I want to ask, here in problems like this, 95th percentile and 99th percentile are important. Let's understand why. If let's say my 99th percentile is 4 days. So let's say my 95th percentile is 4 days and my 99th percentile is, let's say, 5.6 days. These two numbers will tell me a lot about customer satisfaction. Let's understand why. What this is telling me is that 99% of orders were delivered within 5.6 days from the time of placing the order to the time it was delivered to the customer, right? And that is good because 99% of your customers got it within 5.5 days. Of course, there are 1% of users or customers who placed order who didn't reach it who didn't get their placement in 5.6 days. And now your question, if you're managing this supply chain, if you're responsible for delivering orders on time, you would say, okay, 1%, I need to double down and reduce this number, right? So if your 95th percentile is 4 days, you know that there are 5% of customers who are still not getting their product within 4 days. And now you would say, I want to understand why that's happening. So a single number like a 95th percentile or a 99th percentile could be extremely important. It's a single number that will help you very well in understanding whether your customers are happy or not. Okay, so a lot of times people use percentiles instead of standard deviations and things like that.